Hello, I am 3-8 students. I'm going to go over section 7.8 with you. So 7.8 is about equations with radicals. All right, so let me give you some steps on how to do this. We'll do some examples together after that. So, excuse me. So solving equations with radicals. The first thing you're going to want to do is you're going to want to isolate the radical. So what that means is you want to get the radical, excuse me on that. You want to get the radical by itself, okay, on one side. Once you isolate the radical, then you need to square, if you have a square root. You would cube if you have a cube root, so forth and so on. Okay, so you need to square both sides. And again, realize that it says both sides, not each individual term. So be very careful with that. If you got to square the whole side, square the whole side. Or cube the whole side, cube the whole side. So step 3, you're going to solve the equation. And then an important part of this is you must check your answers because sometimes you'll get extraneous solutions. So you always have to make sure you check your answers into the original equation. All right, so that's what we're going to do today. You're going to isolate, get rid of your radical, solve, and then check. So let's try some examples with this. So example 1, let's solve for x. You have the square root of x plus 2 is equal to 9. So step 1 is your radical isolated. Yeah, it is, because we have the square root equal. So we're good with step 1. So now step 2, how do you get rid of a square root? Well, to get rid of a square root, you got to square it. So we're going to square the whole left side and we're going to square the whole right side. Okay, so what happens when you square a square root? They cancel each other out, and 9 squared is 81. Okay, so now to solve for x, I'm going to subtract 2, which is 79. Now, before I box my answer, I have to check it. And what you're going to do is you're going to check into the original equation. So the square root of x plus 2 is equal to 9. Again, not with the squares around it, but the original equation, that's where I need to check it in. So if I plug in 79, 79 plus 2 is 81. Square root of 81 is 9, so we're good. Always, always, always make sure you're checking your answers. Okay, example 2. I'm going to solve for x again. Say we have x plus the square root of x minus 3 minus 5 is equal to 0. All right, so step 1, do we have a radical by itself? No, we don't. So we got to get it by itself. So I'm going to leave it here. So the square root of x minus 3, and I'm going to move everything to the other side. So I'm going to subtract this x over, and I'm going to add that 5 over. So now I have the radical by itself. Now, how do we get rid of a square root? We square. And again, it's the whole side. So I'm going to square this whole side. I'm going to square that whole side. So square and square root cancel each other out. And then here, you're going to either write it twice and distribute, or, as I would prefer you do, you're going to use the pattern. So square the first would be x squared. If I multiply those and double, I would get negative 10x. And then square the last thing would be 25. Whenever you see an x squared to solve, you want to be equal to 0. So I'm going to move everything over to the right-hand side. So keep my x squared here. When I subtract that, that's negative 11. When I add the 3, that gives me 28. And we need to factor it now. So if you guys use a star, think of what two numbers add to negative 11 but multiply to 28. You're going to get x minus 7 and x minus 4. If I solve this first one, I would get 7. Solve the second one, I would get 4. But again, before I box my answer, I've got to check. And again, you're going to check into the original equation when you have done nothing to it yet. So let's go ahead and check that out. So if I plug in 7, it's just 7. And again, 7. So 7 minus 3 is 4. The square root of 4 is 2. So far I have 7 plus 2, which is 9. And then 9 minus 5, is that 0? No, it's not. So this so far is an extraneous solution. Now let's try 4. If I plug in 4, it's 4. If I plug in 4, 4 minus 3 is 1. The square root of 1 is 1. So far I have 4 plus 1, which is 5. And 5 minus 5, is that 0? Yes, it is. So our answer is that x is equal to 4. And 7, again, is not one of our answers. It was an extraneous solution. Okay, let's try number 3. Let's solve for x. I have the square root of x minus 3 is equal to the square root of 2 minus the square root of x. Okay, so first I asked myself, is my radical isolated? Well, I do have a radical isolated, so I'm going to say yes, I do. So now how do I get rid of the square root? I'm going to square. So I'm going to square this whole side. I'm going to square that whole side. When you square square root, they cancel out. Now here is where it's a little tougher. It's still not bad, but sometimes people have a hard time seeing this one. So I'm going to use my pattern. So square the first. Root 2 squared is 2. And now on the inside, we're going to multiply and double. If I multiply these two together, that'd be a negative root 2x. But again, you got to double it, so I have a negative 2 of the root 2x's. Okay, and then we're going to square the last, so I know it's positive. And when you square that, that's going to cancel out, leaving you with an x. Okay, now I see I have another radical. So now I got to get that radical isolated. So what I'm going to do is I'm going to subtract that x over, so it cancels out. I am going to subtract that 2, which is negative 5, and then I got negative 2 root 2x. So now at this point, if I wanted to, I could divide by negative 2, but I don't know that I want to deal with a fraction. So I'm going to square both sides. So I'm going to square this whole side, and I'm going to square that whole side. A negative 5 squared is 25. A negative 2 squared is a 4. And when I square square root, they cancel out, leaving me with 2x. So I have 25 is equal to 8x. Divide both sides by 8. I'm going to have 25 eighths. Now, before I box this, I've got to check it. And again, I'm going to check it into the original. So again, without my red pen, I'm going to check that original. All right, I'm going to use my calculator because it's got a fraction. And I don't really feel like doing that in my head. All right, so here we go. The square root, my x is 25 eighths, and I still have a minus 3. So that's what the left side would be. So now on the right side, I got the square root of 2 minus the square root of x, which we found to be 25 eighths. And a positive and a negative definitely do not equal each other. And since that was the only answer I got, there is no solution to this problem, because the only solution we got was extraneous. All right, let's try example 4. So example 4, let's solve for x. We have 2/3 times the 4th root of x is equal to 20. All right, so first thing, I have to get this radical isolated. So how do I get rid of a 2/3? I multiply by the reciprocal. So I'm going to multiply by 3/2 on that side and 3/2 on that side. So those cancel out to leave me with the 4th root of x. And 3/2 of 20 would be 30. Okay, so now how do I get rid of a 4th root? I take it to the 4th power. So I'm going to take this side to the 4th power and that side to the 4th power. So those cancel out, leaving an x. And then in my calculator, 30 to the 4th. I'm sorry, yeah, 30 to the 4th is 810000. Now all I got to do is check. And again, when I'm checking into the original. So this one here, not the red. So let's check and see if 2/3 times the 810000, right? I think I have too many zeros. 1, 2, 3, 4, 1, 2, 3, 4. I have too many. Okay. A 4th root is the same as a 1/4 power. So I'm just going to take it to the 1/4 power. And I get 20, which is what we have. So that is correct. Okay, I believe I have one more for you. Yes, I do. All right, so here is our last example. Example number 5. Now, if you'd like to challenge yourself, go ahead and pause the video and see if you, once I give you the problem, pause the video and see if you can do it. Otherwise, here we go. So you got the square root of 2x plus 7 minus the square root of x plus 3 is equal to 1. So again, those of you that want the challenge, go ahead and pause and see if you can do it. Okay, otherwise, here we go. So first thing is, do I have a radical isolated? No, I don't. So I'm going to do the harder one to get the one we isolated. And plus, I don't want a negative, so I would rather move that one over. So I'm going to say the square root of 2x plus 7 is equal to the square root of x plus 3 plus that 1. Okay, now that I have a radical isolated, to get rid of my square root, I'm going to square both sides. So I'm going to square that whole side, and I'm going to square that whole side. Those cancel out, leaving me with 2x plus 7. And over here, I'm going to use my pattern. So if I square the first, the square and the square root just cancel out. If I multiply 1 times that, it's just root x plus 3, but when I double it, it's 2 of those root x plus 3's. And then square the last is 1. All right, so I see I have another radical, so I got to get it by itself. So I need to move the x over, which leaves an x, and then 3 and 1 make 4. So if I subtract that over, that would leave me with 3. And then I have 2 times the square root of x plus 3. Now, if I divide both sides by 2, so I'm sorry if that doesn't look like a 2. If I divide both sides by 2, it wouldn't make it any prettier, so I'm just going to leave it here. So to get rid of a square root, I'm going to square, again, both sides, not each individual thing, both sides. Let's use our pattern. Square the first is x squared. Multiply these as 3x. Double is 6x. Square the last is 9. Over here, 2 squared is 4. And when you square a square root, they just cancel out. Okay, so now just let me distribute that. So that would be 4x plus 12. Now, whenever I see an x squared, I know I need to be equal to 0 to solve. So I'm going to move everything over here to the left. So I have x squared minus that 4x is 2x, minus that 12 is negative 3 equals 0. So now I'm going to factor it. So if I use a star, what two numbers can you think of that add to 2 but multiply to negative 3? That would be a positive 3 and a negative 1. So if I solve this first one, I'm going to get negative 3. And if I solve that one, I'm going to get 1. All right, before I box my answer, I've got to check both solutions. So let's do the negative 3 first. So 2 times a negative 3 is negative 6. Negative 6 plus 7 is 1. The square root of 1 is 1. And then here, if I plug in negative 3, negative 3 plus 3 is 0. Square root of 0 is 0. So 1 minus 0 is 1. That one's good. So now I'm going to check the 1. If I plug in 1, 2 times 1 is 2, plus 7 is 9. The square root of 9 is 3. And if I come over here, plug in the 1, 1 plus 3 is 4. The square root of 4 is 2. So 3 minus the 2 gives me a 1. So these ones both work. All right, so that is how you solve with radicals. Good luck with your work. And if you have any questions, just let us know.